Hello everybody, hope you're having a good day today. And today we're going to be continuing on with our Tic Tac Toe series. So last time we had this and we just basically created the board. We wrote a title and we just created the board, and like right now when you click on it nothing really happens. So today we're going to be working on the mouse events and also the Tic Tac Toe API class that we have here. So that's the plan for today. Hope you're excited and let's get started. Alright, so let's get started with the mouse events. So we'll go to our board class, and what we're going to use for the mouse events is called a mouse adapter, and it basically oops, not mouse handler, mouse adapter. And what it basically is it allows us to have mouse methods, and it can directly interact with our keyboard. And there's also something called the mouse listener and mouse motion listener. We could use those as well, but this is like the parent class of those, and this allows us to add methods, add whichever methods that we want to override, and we don't need all the methods like mouse move, mouse press, all of that stuff. So we can just get the ones that we need. So for this we're only going to need mouse pressed. So mouse pressed, and it's going to have a mouse event E. And so here we're going to have mx, and what this is oops, okay, can't spell get. So what this basically, let me just write this out and I'll explain. So what this basically does is it gets, whenever you click on the, oops, why is this in here? Alright, so anyways, what this basically does is, yeah, it's because of this, so make sure that you don't import the wrong thing. Anyways, here, what this means is that it's gonna get so whenever you press on the square or the board, it's gonna call this method automatically, and what this is going to be is it's going to get the mouse event, and it's going to get the X position of your mouse, or the cursor basically. So and we're storing those as an int. So basically if I click here, this would return something, so like X comma Y coordinate that I clicked on. So that's what these two lines mean. And here, before we move forward, we need to actually create a few more methods here. So what we're going to do is we're going to have a public int, and we're going to have a get row click. So it's going to return what row we clicked on, and this will also allow us to make sure that we're actually clicking on the board at the same time, because we don't want to click on some random place and get something returned to us as we're clicking on the board when we're not. So we're going to pass in the mx and my here, and what we're going to do is we're going to basically iterate through the two-dimensional array. So just like how we've been doing it. So oops, so like that. Let me just get rid of this line. So just like this, right? So we're gonna do that, and so let me just write this up actually. All right. So this, and what we're gonna do here is we're gonna check the y coordinates, because this is rows, and rows are like this, right? So this would be one row, 8, 8, 8. This is one row. So we want to check the actual y coordinates to make sure that we're getting our row clicked, and that's sort of how it works. And it's going to be sort of flipped, and it might seem confusing, but it's just how it works technically. So we're going to check if the my is greater than or equal to the coordinate, the board square dot get row. So dot get row, so that's the row, minus 1 times the square length plus the initial value that we had, so plus 90. So that's where our starting point was from the y all the way down. So what it's basically doing is sort of how we drew it up here, and that's sort of like this. As you can see here, we did squared length times plus 90. So what we're doing is we're getting the row, which is the j here. In this case, that's the j, and we're checking if that my where we clicked on is greater than this j times the square length plus 90. So it's basically getting the total range, the starting point basically. So if it's greater than that starting y value, and then we're gonna add an and then we're gonna check if it's greater than if it's less than the left or the rightmost, so the right corner. So if you imagine a square kind of like this, so we're saying we're trying to get where this first sentence is basically checking if the place we click on is greater than this left corner or y position, and now on the and we're going to check if it's less than this right corner y position. So in that case we know that that click was inside that row. So and to do that, we're just going to do the same thing pretty much. Instead, we're just going to flip it around, and we're going to do same ij and then get row, not g, dot get row, and then -1, and then again. And here, why we're doing -1 is because of the array indices. So if we don't do -1, we're going to get some array index out of bounds, because we're storing row 1, 2, 3, but indexes are 0, 1, 2, like that. So, and this is going to be the same thing here, and then we're just going to add the square length, because that's how long each of the things is. So that's why we're doing that. And this, and then basically this just means, as I said, the right corner. So we're checking if it's greater than that and less than that. Let me see if I messed up my parentheses somewhere. And yeah, so that's what we need. And if that is true, that means we can just return. So we can just return the board. We can just return the row pretty much, right? So the date.getRow. So we can just return that. And if it's not there, we'll just return -1. That means we didn't find it. That will be like our code to see if it's there or not. And here we're gonna do another one for the column clicked. So actually we can really copy paste this, and I'll show what I mean here. So I'm gonna change this to column clicked, and instead we're gonna do the exact same things, except we're gonna check with mx. So wherever we have my, we're gonna check with mx, and this is gonna be get column now, and everywhere we're gonna have get column, and we're gonna have to change some of the coordinates for like the square length stuff. So here we started our x coordinate with x, and in our other one with 95. So this part with 95. So again, what this is doing is again checking the leftmost, and it's checking the x position. So actually, in fact, sorry, I think I might have said something wrong. So this is checking the x position of this and this coordinate. So that's what this is checking, and this is checking the x coordinate, the y coordinate of the leftmost and the bottom corner right here. So if there's a corner here, that's what I mean. So in fact, something like alright, so I'll try to explain it actually. So let's say we had something like this. So imagine these 6 like brackets made up a square, or made up a shape for us. So what we check is we check if this in this get column or get row, we're checking if this y value is like if the place we click, if is equal to this, or is in between this. So if that's in between that, then we can consider that like a row, that's a possible move on the board. If it's not, then obviously it's not clicking on any row or column. And here it's doing the exact same thing, except it's checking the x. So it's checking this and this, and if it's in between that, it will allow it to get the row. So that's essentially what we're doing here. So that's like 2 helper methods that we just created. Alright, so now we can go back to our mouse pressed here. Right, yep, right there. So what we're gonna do here is we're gonna see if, so we're gonna have an if statement. I'm gonna say if row clicked, obviously we're gonna pass it in our mx_my. If it's not equal to -1, that means we clicked on a square, and if we clicked on a perfect row or a column, and we didn't just click right anywhere else. Same thing we're gonna do with get column clicked, and if it's also not equal to -1, and we'll make sure, and remember we had this boolean here, winner found. So if we don't have a winner yet, that means we want to keep like having the mouse clicks to work. So if we find a winner, we don't want the person to be changing the board after someone's won. So we don't want that, right? So we're going to do it until there's no winner. So if there is no winner, we're going to keep asking for mouse input, right? So what we're going to do is I'm going to store these rows in a value, and I'm going to say get row clicked, get row clicked, not column. And then we're going to do the same thing for column. I'm just going to call it square column, and get column clicked. Right. So we just got them in variables, and here's where stuff can kind of get a bit complicated. So realistically, when we're looking at a 3x3 in our perspective, the column is technically the row that we're referring to, and the row is technically the column. It's just how arrays are kind of weird. So in this case, right, so we'd say that this is row 1. Let's say this one. Let's say it's a row 1, column 3, right? But in arrays, this is technically like the third column and then 1, the first row, right? So that's actually technically flipped. So we want to be aware of that. So this is sort of like the row in terms of our perspective. So that's why here we're checking if the board square column -1, and again -1 because of the array indices thing, and square row -1. So that's why I mentioned that, because I didn't want it to be complicated, and that's why we're going to get our get piece that we have in our board in our squares class here. So we're going to call the get piece method right here, and it's going to give us the piece. So get piece, and then we're going to get the value of the piece, which is a string, and we're going to make sure it's not equal. Sorry, we're going to make sure if it's equal to so here. So if we have an empty. So what this means is that there's nothing there, right? So there's nothing there. If there's nothing there, then we'll allow it. So what we're going to do is we'll have a current turn, and in our API, so in our Tic Tac Toe API, we're going to create a change turns method. And you probably remember this from the one that we did in the command line, and that's what we're going to do. And we're just going to pass it the current turn. And it'll give an error for now because we haven't done that method yet, but that's fine. Again, then what we're going to do is we're going to basically, so we want to first change the term. And why it might seem like, okay, why do we have the same if statement twice? But that's because at the start, if you don't change the turn automatically, because right now if you look at it, we're initializing to empty, so we want it right off the bat to actually change to turn. So it'll automatically do this at the start if you click on the place. So that's why we have two separate if statements. We could do it differently, but I have it done this way. And here's where we actually put the logic of putting the piece on that square. So what we're going to do is, again, we're going to refer to this. In fact, I'll just take this. So we're going to refer to this, right? And if it's empty, what we're going to do is we're going to basically do set piece. We're going to set the piece, right? And we're going to set a new piece, and we're going to say that the value is the current turn, and the square row is obviously the row, and then the square column. Oops, square column. So there we go. And we're going to increment the moves made. Now let me just check. I think we have an error here in the square class. So okay, we called this set colon a call for some reason. It should be set piece. So that was a problem. But here we go. So we have set piece here. And now after that we have a winner, right? We'll check for a winner every time. And this is going to be done with our API. So we're going to do winner, and we're going to pass it the board, the rows, and the columns. All right, and then we'll do the winner stuff later. Okay, so that for now, if we were to, for example, to just comment this out for now, and let's just go ahead and run this and see what we have. In fact, before we run it, we're actually missing a thing. So here in the game, we want to make sure that you actually don't want to forget this, otherwise you're going to be confused. So basically we need to add a mouse. Oops, not there. So in the game and the constructor, we want to actually add a mouse listener to the board instance. And we want to do this so that means Java knows right off the bat that there's a mouse listener, or there's listening for mouse keys and key input, or the mouse input in the board class. So that's sort of what it's doing. And I might have said key input before, I meant mouse. Alright. So yeah, that's what we're trying to do here. And you have to have that line in order for Java. Alright, so before we run and see what happens, I said we commented these out, and this will actually make a difference, as you'll see soon. Let's make sure we have everything right. So get row and clicked. Make sure it's times square length plus 90. I don't think I had that before, but have this. Basically what we're doing is this entire thing plus the square length, so we can get like the entire x or y coordinate of the square, so we can check. It allows for proper mouse checking inside of the row or column or of the box. Same thing here, times square length times 95 plus square length plus 1. Oops, square length plus 1. And here I changed a few things actually. So with the board, when we were creating a new board when it was null, I changed it so we're using the other constructor, so we can actually get rid of it in our square class. We don't need the empty args constructor, and same thing with the piece. We don't really need it. It's not necessary. We can just do it through here, and it allows better, because last time we just made these in -1 in the square, but that's wrong, because now when we're checking for the row clicked, we're always going to return a -1 then, because even if we're clicking on a right row, it's going to give us -1. And I just removed it for the piece because it really isn't necessary and just adds to the complexity, I think. So here instead we're making a new square, and then we're doing I+1, so we're giving it the right row and the right column, J+1. We're just creating a new piece with the current turn, and then like undefined rows, pretty much, or undefined rows and columns. So if we were to run this right now, you might think that it's gonna work, and I'm clicking here, but as you can see, there's nothing actually getting put there. And why is that? And the main turn is empty, and as I said, we commented this out, so we're not actually getting a right, like we're not getting a turn. So that's actually why we have this if statement here, so we can actually get a turn right off the bat. So we need to actually work with our API now to make this work, and same with the here. So I think the best thing to do now would be to, let's just go to our API and make this work. So let's go to Tic Tac Toe API, and let's get started with this class. So it's gonna, as you're gonna see, it's gonna be very similar to the one that we made with the command line. So the part one, and if none of you have checked it out, go check it out. I'll probably put a card and a link in the description below as well. So as you can see, we're gonna have a player, two player 1, player 2, string win type, and this is different a bit. Why? Because I'm actually gonna be checking for what kind of win is it. Is it a row win? Is it a column win? Is it a diagonal win? So that's what we're gonna do. So first things first, we'll just create an no-args constructor here, and what we're going to do is we're just going to initialize. I'm going to say player 1 is going to be always the O, and then player 2 is always going to be the X. And we could like make it random as well, but I'm just going to do it this way just to keep it simple. Win tab, I'm just going to give an empty space, so it's going to be like a non-win tab pretty much. First things first, let's do our public string change turns. So this is a very simple. Actually, it's gonna be very simple. It's gonna be very similar, as I said already, like a bunch of times, to the other one that we did. So we're gonna do if turn equals empty. So why are we checking for this? Well, we're checking for this because this is what's gonna happen the first time we come in. So first time we call change turns from board here, we have an empty change turn. So we wanna make it so always O starts. That's what I'm doing here. Also, we're gonna check if the turn is equal to the player 1. So if it's not the string, just a player 1. So if both the strings are equal, so like if they're both O's, that means the turn was O, and we want to basically make the turn equal to we're just gonna make the turn equal to player 2. That's what we want our turn to be. And lastly, if it was turn, not that, we get rid. Yeah. Lastly, if our turn wasn't that means the new turn will be player 1. So we're basically switching the turns, and at the end we'll return the turn back. And this will basically make sure that we change turns properly. So in fact, right now I think we could run it, and just to prove the point of why it wasn't working. So as you can see, we'll uncomment it here, and we should see that it will work. And see it, as you can see, I'm clicking on it and the turns are changing, and I'm just clicking, and after I click on it, nothing will happen. In this case, it would be a diagonal win, but as I said, we don't have the wins yet, so there's no checking here. So the API, let's do the winner. So this method is sort of a bit more complicated than the last winner class that we did. Even the last one was pretty complicated. This one just has a bit more lines. So this one, we're going to return a square. So we're actually going to return this, like the first square of the win, and you'll see that. And you could return any square on that diagonal, but we're just going to return the first one to keep it simple. So what we're going to do is, we're going to check column wins first. And as I've said already, when we're checking columns, in our perspective is flipped from the array's perspective. So we're going to check. So for column wins, in our opinion, we're going to actually check the rows. So we're gonna check the rows, and we're gonna return the rows. Actually, so that's actually what we're gonna do. So what we're gonna do is we're gonna do I equals 0 and then less than the rows, right? And then plus equals. And here we don't have rows, and that's because we will actually get past that. So In fact, I should probably write our parameters in. So we're gonna get the board, obviously, right? We're gonna get the rows and the columns of the board. So there we go. So we got those, and we're gonna enter through the rows, and we're gonna check if board at I0. And I've already explained why I'm doing it like this, and this is the same logic we had in the other video, so I would suggest check that out before this one. But essentially, I'm going to get the piece, and then we're going to get the value, and we're going to check if it's equal to I and then column 1. So we're keeping the rows the same, which is I, and we're changing the column. So we're checking every column to see if that piece is equal to the next piece in that column. And then same thing, I'm just gonna copy this because it's just gonna be less typing. And instead I'm gonna make this 1, I'm gonna make this 2, and we're gonna do the same thing essentially again. Copy that, and we're gonna check 0 and 2. And you don't really need to do this like that many copies, but I'm just gonna do it that way. Oops, I'm just gonna give a parenthesis so it's in the same. So this basically, essentially, right? So in fact, one more thing I have to do is, again, here we're gonna have to do get piece and get value here again, and we're just gonna take these again because we're comparing the strings here. And we could write a equals method in our board class, our squares class, but sometimes it doesn't actually work, and you'll see that. But we're gonna write one in anyways. But you're gonna see for this case I'm not doing it because it didn't really work. And last thing, this one we're just gonna do because it's just a good thing to do. I'm gonna take this line here, right? I'm just gonna take I'm gonna take this entire line here. And what we're gonna check here is we're not gonna check if the board is equal to something else. We're just gonna check if it's not empty, because if it's empty, then we don't really want to check it because we don't have anything to do with that. So we're gonna do that for all of them. We're just gonna make sure none of them are empty, because then in that case we could just have all empties at the start and we could say, oh, that's a winner, and obviously that is not a winner. So again, we're doing that here. So we're checking if the columns at 0, 1, 2 are not empty. And once we do that, and that means here we check all the columns, and once we do that, we can just say our win type is a column win. So we won by column, and we're doing this win type thing so we can actually draw the lines that I showed in the first video. Last video, and so we're gonna return I'm just gonna return the first one, but you could return essentially the first one or the second one because they're all the same. But I'm just gonna return it for simplicity's sake. Here we're gonna check the row wins, and it's actually the same thing almost. And I'm gonna copy this, and you'll see why. So here, as I said, we're gonna go through the columns, and what we're gonna do is we're changing these, and I did this last time as well, and I kind of messed up sometimes, but make sure not to mess up here. So 0 and I, we're just gonna flip these around, and this is essentially doing the exact same opposite thing. So it's gonna keep the columns the same, but the rows different. So we're gonna check the rows, the rows. But realistically, what we're doing, if you think about a 3x3 in our way, we're actually keeping the rows the same, the same, or we're changing the column in our way, because arrays and our way of doing the boards and stuff is a little bit different. It's in fact the opposite. So that's why this flipping thing works, and that's why we're checking the columns here and not the rows for row ones. So as I said, I'm just gonna flip these around, and I'm just gonna fast forward to this so you'll see here. So just flip all of these around. That's sort of the key here. So we flipped all of them around, right? And after we do that, let's just make sure, yep, everything looks flipped around except this. Actually, no, this is right. Alright, so now we're just gonna say row type is that, and we're gonna flip this around as well. And I'm returning the first one as I said already, but that's because I'm just keeping it simple. Alright, so now here we're gonna go to our board class, and we're actually gonna make the equals method. And it's better to make the equals method for checking for diagonal wins than it is for the the checking for the row and column wins. So here the equals method for the square is actually very simple. So again, boolean equals, and this is sort of like overriding the objects equals method, which is not good. So we're first going to check if O is like the object that we get, so the cosmic superclass type. If it's not an instance of square, then we can't really compare it for anything, so we're just going to return false here. And then you can actually we're going to downcast it pretty much to a square type. And this is safe, and we don't have to use generics here because we know automatically it's already a square type from this this line. And now here, all I'm going to do is we're going to check if get piece. So the piece here is equal to the other object that we got, dot get piece, and if it is, we're going to return true. And I know this is wrong because it's supposed to be a method, but return true and then return false if it's not. So here, oh, we don't have the get piece. Oh, I'm doing it in the wrong place, of course. So not the board, we want to take this method and put it in the square. So right here. So we want to put it here. And that means since we're doing get piece dot equals, that means we need to have an equals method in our piece class as well. So we're going to do almost the exact same thing here. In fact, I'm going to copy paste this. But instead, we're obviously going to check if it's a piece subtype, and then we're going to subtype it to piece. What we're going to do here is instead, since these are strings, it's going to be easy to compare. So dot value, and then I'm going to check if that value, so we're going to check if the x's are equal to the x's and the o's are equal to the o's, and then here, in fact, I'm going to say p dot get value. And I know that I don't have this name, but I'm just going to change this to p. So that's it. That's essentially the equals method. So we can go back to our Tic Tac Toe API, and here we're going to do the diagonal checks. So for diagonal checks, I'm going to write that here. Check diagonal wins. The wins. So for the diagonal wins, what we're going to do is it's very similar. So since it's a 3x3, it makes it actually very simple to do. And what we're going to do is board at 0, 2, and it's going to check each individual square on the two diagonals that we have possible. So we're going to check here if it's equal to 1, 1. So we're checking the leftmost square to the rightmost square on the bottom. So like this diagonal, if you follow my cursor, so this diagonal is what we're checking here. And we're checking it like the array way, but it doesn't really matter here because technically, regardless, it's still going to be the same, and that's how like diagonals work. So same thing. So we're checked this way, and so if we see that, sorry, I meant this diagonal. So we're doing this diagonal first. So 0 row and then column 2. So this diagonal. Sorry, my bad. This diagonal. So we're checking if that's it, and we're just gonna make sure that the first board square is not null. So like the piece on it is not null, because if it's null, then obviously it can't be a winner, right? So that's the first thing we're checking, and if it is, we're just saying the win type is diagonal win. Oops, the formatting's off, but I'll just save and do that, and then we're just gonna return the first board. So this should be board at 0, 2, by the way. Just make sure this one where we're checking for null. I want to make the board at 0, 2, and I'm just going to return that actually. So I'm just going to return the first one always, as I said before. Same thing, and this is going to check for this diagonal now, the one that I said before, and it's going to be pretty much the same thing, except this is just going to be the same like numbers now. So 0, 0, that kind of stuff, and same thing here. I'm just going to return that. So this is essentially our win. It's done. And lastly, we just want to return null if there is no winner. So I'm going to go back to the board class here and just uncomment that. Alright, so I think now let's do the win path, like the winning path, to draw the winning path method, and then we can set up our winner. So here we have our draw winning path method, and we should have a graphics G in here because we want to draw it obviously, and then square winner. So we want, as you see, the top, our winner method returns a square, and we're going to take that square and draw from it, and we want a square length, and that's how we're going to do it. And it is static, so I could technically access it from another class, but I'm not going to do that right now. And here I'm just going to add AWT. I could just add like AWT.graphics, but I'm a little bit too lazy, so I'm just going to do that. And so what we're going to do is we're going to set the color red. So whenever we draw that winning path, I want it to be red, so it kind of pops out. And here I'm going to use something called graphics 2D, and this is going to allow us to get that like a thicker line pretty much. So graphics 2D, and I'm going to set stroke, and this allows it to set a stroke, so basic stroke, and this is sort of the reason why I didn't want to add everything individually from the AWT, and I just added everything, and it's going to be 8. So it's going to be like 8 times bigger than the actual normal line. So now to draw the winning path, I'm going to take the win type and do it according to that. So for win type, win type, some autocomplete please. Okay, and win type, and if it's a diagonal win, then we're gonna have to do 2 different actual drawings for that, because it's obviously a bit more complicated than it seems. So there's 2 different diagonals. So one could be when the winner dot get column. So if that -1, if it's 0, that means we know we're on this diagonal. So if you think about my cursor, it's like this diagonal. So if we get that one, what we're going to do is we're going to draw a line from, so it's going to be x1, y1, x2, y2, that's like the parameters. So we're going to do the winner, so we're going to do, winner dot to get the column, right, -1 because of the array thing, times the square length that we got, right, the square length, plus 100, so that's like the x position, and the y position is almost the same thing, except it's just plus 90 instead. And then here what we're gonna do is we're gonna go till the end of this, the rightmost like square. So 3 plus 100, and then same thing for the y, except plus 90. So plus 90. Alright, and that should be it for this one, this row. And then other case is I'm adding an else if, but it's not necessary here. But the other case is if the get column -1 is equal to 2. That means we're getting this diagonal now. So from this point to this, it's that diagonal. And what this will do is we'll draw a line, and as you can see, we already got the parameters there. Those are the parameters. We're gonna do those same, almost the exact same thing actually. So get column -1. It's just the endpoints are gonna change, and also the x here is gonna be different. So we're gonna do times square length as we did. Square length plus 100, and then we're gonna do plus the square length. So then we actually get the rightmost side for our x coordinates. And for the y1 at least, so what we're gonna do for that is we're gonna do winner.getRow, and you'll see why. It'll make the y value calculation a lot easier. So in fact, actually up here where we did this, we actually want to make get row. So y we're gonna deal with the rows, and the x we're gonna deal with columns, right? And then we're gonna do times square length plus 90. And then this one I can actually just make it 100 because that's the starting x position that we have a default. And then this is just going to be square length times 3 plus the 90 that we have. And that should do it. Those are the diagonal lines that we can draw. Now else if here we're going to do if the win type is a row, that equals row. So if it's a row win type, then we only need one line, and this will work for every single row. So what we're going to do is we're going to take the winner, and then we're going to get the row that it has, -1, and then we're going to do times square length, times square length plus 100, and same thing, except now we're going to deal with the columns here. And since, as I said before, our row is kind of like according to array, this will work like that. So row is kind of like our x, and columns kind of like our y here. So what we're doing here is we're going to do -1 times the square length plus 200, and we're doing that because that's 200. that actually will take us all the way to the end of our. Take us to the middle. So it'll take us to the middle of our row or the box. So that's why we're doing a plus 200 here, and that's why it also works kind of that way as well. So as I said, we can actually put this inside. So winner dot get column, so -1 times the square length plus 100. or plus 200, sorry. And then what we want to do is our x coordinates obviously going to be all the way to the end, so times 3 plus 100. And our y is not going to change, so we can just copy paste this and it'll be the exact same thing. So that's essentially it. Oops, can't spell. Square length, right? So that's the row, and then lastly we're going to do column. And I'm I'm putting an else if here, and as I said, you don't really need it, but I'm doing it because it'll make things more clear. Here we're doing also almost very similar things here. So our x1, so our starting x position is going to be depending on the row again here. So, but it's mostly not going to depend on the row, but this one we are starting off with the row again. Minus 1 times the square length plus 200. So here we're doing the same thing we did for the top, except we're doing the plus 200 here, and this is allowing us to sort of center the line on that row or the win, pretty much, right? So now here the y is going to be according to the column, so get column and minus 1 again times square length plus 90. So that's allowing us to do that, and now the x position won't change, right? That doesn't change for us, only the y does, because it's a column, so it's like up and down. So that's that. So x doesn't change, and then now we're gonna have to change the column. So I mean the y value, right? So we're gonna have to change the y value. So since we're changing y value, what we're gonna do is it's just gonna be square length, just like we did for the x, square length times 3 plus our starting y, so plus 90. So that's it. That's essentially the draw WinPath, right? And I'm just gonna do this other method here, and because it's very simple and it doesn't have that much it's not like too complicated either. So it's not like a lot of logic here. It's just game result, and it's gonna draw a few stuff to the screen. So game result, and what we're going to do is obviously, okay, so we're going to get graphics G here, and if I can spell graphics, G, and then we're going to get string result, right? And we're going to have still set font because we love to see stuff that looks nice, not the ugly stuff, right? So font.bold, and we're just going to do 75, we're just going to make it something large, right? And result, if that is equal to a tie, if that is a tie, obviously. So if that's a tie, we're just gonna set color to cyan, and it doesn't really matter. You can make whatever color you want. I just chose cyan here. And what we're gonna do is we're gonna draw the string at game tied. And here, what I did was I tried to center it as much as possible. So I did frame.width divided by 2 minus 220, so that's like about the size of the 75 font letter. And then I'm just going to do frame height minus a certain amount, because I always wanted a certain 40 pixels off the bottom of the screen. So that's essentially what we do for the game tied. Else, I'm going to set a different color, so I chose like a lightish kind of color, I guess, set color. And so this is the color I chose, RGB. So 209, 242, and 235 is like the color I choose, and you can check it out. And what I'm gonna do is draw a string here, and then we're gonna do player, player, and then we're gonna do in here. I'm just gonna do the slash quote, so it's like a single quote plus the result. So what we're doing in the results is we're passing in the X or O, so depending on who won. And so I'm gonna pass in this, and I'm gonna say 1 exclamation mark because we want to make them feel happy, and then frame.width divided by 2 minus 290. So it's because of more letters here, so that's why we gotta have a different number than this. And again, same thing. I wanted always 40 off the bottom of the screen. So that's essentially game result done. So our API is pretty much done. So it has most of the logic that we need in the game. So now we're going to go back to the board class, and add some of the rest of the stuff. So what we're gonna do here is go to the mouse pressed again here, so where we left off here, and then here we're gonna check. So remember when we made our winner method, it returned null if there was no winner. So we're gonna check if it's not null, obviously, and we're gonna check if this winner is not like an empty piece. So if it's like get piece dot get value, and if this value is equal to an empty string, then we know, okay, so it's not really a winner, right? Either. So there's two ways we can have that, and then we're gonna say winner found is true. And we're making this boolean true because we're gonna have a different way of handling it here. So another thing we can do is if winner is null, and this might seem a little weird, but if the moves made, oops, can I see the end? Okay, if moves made, I can't type. Anyways, moves made is 9. That means the game is a tie. If we don't have a winner and everything is null, still, that means the game is a tie. There's no winner. And I'm still gonna set the winner found to be true. And this might seem a little weird. It was like, why are you making this true, right? But I'm gonna have it because you'll see in a moment. So here we're gonna basically here I'm just gonna have a winner found method if statement, and we're gonna do a few stuff here afterwards. But in fact, I'll just set some. Actually, no, we'll do this later. We'll do this later. All right. So now let's go over to our method here. So our draw method, and after the welcome to Tic Tac Toe stuff, or in fact before, it doesn't really matter. We're just gonna check if there was a winner found. So if there's a winner found, what we're gonna do is if winner found, we're gonna basically check out first of all if winner is not equal to null again, because that case that means the game was a tie, right? So we draw the winning path, we pass in G, we pass in the winner, and basically this is what we pass in, right? If the moves made is 9, so this is where we check for the draw actually. So if moves made is 9, moves made is 9, and the winner is equal to null, we just say API.game result, that thing, and then we pass in G and we pass in the result, which is a tie. Alright, so here, yeah, so if it's not null, so that means this one was just for like drawing the winning path, so diagonal rows or columns. Else what we're going to do is we're going to do API.game result, and we're just going to do G, and the result's going to be the winner dot get piece dot get class to get piece dot to get value. So that's going to be the extra O, oops, get value. So that's what we're going to do there. And then we're going to have an ask to play method, but let's just do the else statements because it's easier. In fact, we already have the else statement actually. So when someone wins, we're actually going to ask them if you want to play again, just like we did for the terminal above, so where this stuff is. So that's why I'm putting this in the else. Alright, so before we go ahead, let me just fix this tic-tac-toe part. So I've made this rows, and let's just make it a row, because here we're checking for row, or we could change either one, and let's actually see if everything runs properly. So I'm going to compile and run. This works. So let's do the row first, I guess. So you can see row wins, and you get the player of that one. Diagonals work. So yep, diagonals work. Let's check this. So yep, and it works. So would you like to play again? This video might be a bit long, but at least we can finish our GUI. In the next few videos we can like focus on making the AI for this game, as that is like our main goal. So first thing I want to do is I want to have this button clicked method. I'm going to do it right above the row clicked. So I'm going to do boolean button clicked, and this one's going to return true or false if you actually click the button. So we're going to have that, and we're going to pass again, or obviously we're going to have mouse event E, and you'll see why we're going to pass this. And here we're going to do an int to bx, and it's going to be the button x and the int to by. It's going to allow us to check for like which button we clicked on and the string button name. So that's going to be like a yes or a no, and you'll see in a moment what I mean. But I'm just going to write this method because it's very easy and very similar to like the previous one that we did. So the rows clicked and stuff, and here again we're going to get the xy. You already know this, right? And it's comma here, periods, comma. Alright, so again we're see if button name equals yes, right? Yes, right? Because we don't want to have random buttons. If we ever add like more buttons, we don't want to make it crowded. And again, we're going to check this thing, and this is what I was sort of going for in the rows and clicks. So if you don't get it, this is what I'm saying here. And bx plus 100, and our button lengths are going to be 100. So xy is going to be 100. The same thing we're going to do for my here. My, and if it's greater than or equal to by and by, or my, sorry, is less than by plus 50. So our buttons are going to be 100 by 50, and we'll return true. Same thing for the no button as well. And I'm writing else if, but we don't really need it because we only have a yes and no button. I'm just doing it so it's more clear. Exact same thing actually for this as well. So yeah, so essentially we're doing the same thing, and if none of these are true, we're just going to do false. So that was the simple method there. And what we're going to do is we're going to go right up here where we had that winner found method, and what we're going to do is if button clicked, and we're passing mouse event 550, 20, and yes. And you might think, what's 550, 20? That's going to be like the coordinates where we put the game. We're going to have a reset game method, and you'll see that. And that means they want to play again. And else if we're going to do the same thing, but different button position, obviously. So it's going to be 670. So we're just changing the x, so they're all going to be in the same line, and it's going to be no. And then we're just going to system.exit. So that meaning if the person doesn't want to play again, we'll just quit the game pretty much and quit the GUI itself. So I think now we should go ahead and actually do the reset game method. I'll just do it above the mouse pressed. So we're going to reset the game, and essentially this is exactly what you think it's going to do. It's going to reset the game. So we're going to reset the moves made to 0. We're going to make the current turn back to what we had. So it's like having another constructor almost, in a sense. And what we're going to do is we're going to iterate through all the rows again, and we're just going to do this almost literally the exact same thing that we had before. So columns. So what we're going to do is we're going to make boarded ij equal to new square, and we'll give it I plus 1, j plus 1, right? Oops, not j equal to 1. J plus 1, we're going to make that new piece, and we're going to give it the current term, and we already know it's empty because we set it up here. And we're just going to give it the undefined kind of rows and columns. So we should reset the board there. We're going to make the winner found obviously false, right? And we're going to do winner equal to null, so that means we no more winners. And we're just going to make player choice, and this player choice will actually come into handy now, and it's going to be like the yes or no stuff, and you'll see. And now I think the main important thing is now we have to make the ask to play again method, and this is the method that will pretty much handle that ask to play again stuff. So ask to play again here, and again graphics G, and again we're going to try to make it pretty here, so font, and Arial bold, and I'm choosing 36 here. You could choose whatever size you want. This is sort of like a stylistic thing, so you can style however you want. These are my colors that I'm choosing. It's up to you what colors you would like. And then we're just gonna ask here, do you want to play again? So would you like to play again? Gonna question mark obviously 20, and this is gonna be 2060. So it's gonna be 20 from the left corner of the GUI and 60 down. And again, I'm just gonna separate it out by pieces. So this is gonna be the boards. I mean the buttons, not the boards. So the color, I have like a greenish color and a red-ish color, I think, right? And I'm gonna do g.fill 3D rectangle, and it's gonna look like it's kind of raised a bit. And the raised is a true or false kind of question. So as I said here, we're gonna have 550 before x and y, and 100 by 50, and then true. So that's like a raised. And then I'm gonna copy this because we have a no button. I'm just gonna change the values here. So this is a different color. So this is like my red kind of color, and then all we're changing is the x here. So 670, as I said before. And then we're just going to draw in the text because you never know, right? Because you don't know what color like what color button represents what all the time. So we're just gonna draw in the text saying yes or no. Oops, draw a string. So it's gonna say yes, and then it's gonna be 565. So it's gonna be a little bit to the left and a little bit down. And then same thing here, and it's gonna be no. Oops, no. And then it's gonna be 695. 695. So now we need to call this ask to play. So we're gonna do it in winner found. So after you find it, then we're just gonna ask to play again, right? And if they don't, obviously we'll kick out. So this should be it actually. Let's check it out. So kind of win. So we got the win. It's gonna ask you, would you like to play again? If I say get a tie, if I can. I don't know why I played that. Alright, so you see game tied, and it'll ask you, would you like to play again? And we can say yes or no. If you want to play yes, you're back to the screen, so it's refreshed. And here, oh, you won. Player X won. Do you want to play again? Yeah, sure. And then, as you can see, the GUI now properly works, properly detects the wins, and we get all of that stuff. So I hope you enjoyed this video. I hope you enjoyed creating the GUI, and I hope you like the GUI in fact. And next video we're going to try to make an AI. So we're going to make, let's say we're like player 0 and then there's a player X, and we're going to try to, basically we're going to play against a computer. Again, thanks for watching. Please like, subscribe to the channel, and I hope to see you soon.